viewers, welcome again to Mathematics and I. It's your favorite presenter, Jeff Nino, and today we are beginning a new topic which is known as coordinate geometry. Okay, now in this series of videos, we are going to be looking at different topics which range from distance between 2 points, to gradients, to the equation of a straight line, to when two gradients are perpendicular, when two gradients are parallel, so on and so forth. But we are going to be taking them one after the other, right, for easy understanding. So the first part of coordinate geometry, which we are going to be looking at today in this video, is known as the distance between 2 points. The distance between 2 points. Naturally, the distance between 2 points is the length of the line segment that is connecting the points. If, for instance, I have point A, and then I have point B, and then a line is drawn. Alright, now the line drawn is actually the distance between point A and point B. So if we should say the line AB is actually 10 centimeters, it simply means the distance between A and B is 10 centimeters. Now another thing you should understand, or another thing you should know, is that now the distance between 2 points can be on a straight line or can also be on a curve. For instance, I can choose to walk from point A to point B, going on a straight pattern. But again, if this is point A and this is point B, I can also choose to go this way. Okay, you see this is curved, but this is straight. Now, the distance between A and B on a straight line is not the same as the distance between A and B when it is curved. Alright, so if I should say this is A and this is B, and then I have a line here which is distance between A and B, and then I have a curve here, and then I say the curve here is 20 centimeters. Now the distance between A and B is not 20 centimeters because this is actually a curve, right? But here the distance between A and B, if here is 10 centimeters, is actually 10 centimeters. Okay, now if you are given questions and then you are told to solve for the distance between 2 points, there's actually a formula which you can apply. Now the formula for solving distance between 2 points is right. Now if we are given the points A equal to x1 and x1, y1, right? And then B equal to x2, y2. Now we are given 2 points. And then we are told to calculate the distance between point A and point B, given these points, alright? Okay? Now I'm given these coordinates, x1, y1, x2, y2. The formula you will apply is this. Now the distance between A and B, okay, is equal to the square root of x2 minus x1 minus x1 squared plus y2 minus y1 squared. Now, this is actually the formula you use when calculating for the distance between 2 points. Now, there's one thing you should understand, that the distance between 2 points, the values of distance between 2 points are always positive. Alright, you can have a negative distance between 2 points. They are always positive. Okay, now if this is the formula for solving distance between 2 points, another thing is how did we come about this formula? How can you prove or how can you show how this formula is actually gotten? Now, let us assume we have 2 points, point A and point B. Alright, and then let's see. And let's plot this in the graph. This is y, and this is a negative y, this is a negative x, and this is a positive x. Alright, now if we have A and B, and we have the distance between them in this format. Alright, now if we want to prove the formula, or if we want to derive a formula for distance between these 2 points, this is what we are going to do. Let us introduce these lines to make this a right angle triangle. Alright, now a right angle triangle with angle 90. Okay, now don't forget we said that in the question, point A was actually x1, y1, okay, and point B was actually x2 and y2. So it means, let us say this is point C. Now it means the distance between, on the vertical side of the right angle triangle, because it is on the y-axis, is y2 minus y1, okay? And the distance between A and C, because it is on the x-axis, is actually x2 minus x1. Okay, now let us say the line connecting A and B, which is actually the hypotenuse of the right angle triangle, let us call this D, which is actually the distance between A and B. Now, if we should apply Pythagoras theorem, okay, which you use when you are solving for a side of a right angle triangle, given the values of the other two sides, this is what we are going to do. Now, according to Pythagoras theorem, when you are calculating for the hypotenuse, you say hypotenuse squared is equal to opposite squared plus adjacent squared. Now let us substitute what we have for these values. Now our hypotenuse is actually D, so here it becomes D squared is equal to, now BC, line BC and line AC can be our opposites or can be our adjacent. Now the reason why we don't know which is actually the opposite here and which is actually the adjacent here is because there is no given angle in the right angle triangle. If for instance I include here as angle theta, now because of the presence of angle theta, it makes line BC becomes the opposite and line AC becomes the adjacent. So if for instance I am using angle beta, it makes automatically line AC becomes the opposite and line BC becomes the adjacent. But because in question there was no angle given, we can take BC as opposite or BC as adjacent, or AC as opposite and AC as what's adjacent. It doesn't really matters. So let's go now. So here it comes. Now, in order to obey the rule of alphabetical orders, let us bring x first before y. So what we have here now is x2 minus x1 all squared, okay, plus y2 minus y1 squared. All right. Now here becomes, if we want to get the distance, if we want to make D, which is the distance, the subject of the formula, it means we have to square both sides. It means the square crosses the equality sign to the right hand side of the equation and becomes a square root. So here becomes distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, which is of course the distance formula for solving the distance between 2 points. So this is how you can actually derive this formula. And the next step which we are going to look at is how we can actually apply this formula in solving problems. So we are going to solve 2 examples, and after the end of the solvings, we will come to the end of the class. Now don't forget, if this is the first time joining us, don't forget to subscribe to our channel, and also don't forget to help share our videos. Alright, time for example. Like I said, we are going to be looking at 2 examples. 2 examples, alright. Okay. Find the distance between the points. Alright, between the points. Okay, 1. Point A has 5, 4, and point B has 3, 2. That's 1. Number 2. Point P has minus 3 comma minus 4, and when Q has minus 2 comma 2. Right. Now let us solve for the distance between A and B and the distance between P and Q. Solution. Okay. Number 1 says point A is actually 5, 4, and point B is actually 3, 2. Now let's label. 5 here becomes x1 and 4 becomes y1, and here also here becomes x2 and 2 becomes y2. That's the first thing you need to do. Now let us apply the formula. The distance between AB according to the formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now let us substitute the values. The distance between A, B becomes the square root of, now x2 is 3 minus x1 is 5 all squared plus y2 is 2 minus y1 is 4 also all squared. Alright, so here becomes distance between A, B becomes square root of, now 3 minus 5 gives us minus 2 raised to the power of 2 plus 2 minus 4 gives us also minus 2 raised to the power of 2. Right. Now let's proceed. The distance between A, B becomes the square root of, now minus 2 raised to the power of 2 simply means minus 2 times minus 2 into 2 places, and that gives us a positive 4 plus minus 2 also raised to the power of 2 gives us a positive 4. And of course, AB, the distance becomes root 8. Now, root 8 is an irrational sort. And so, yes, so what we're going to do now is we're going to simplify root 8. And of course, if we simplify root 8, we are going to get 2 root 2. Now, most of us don't know how I got 2 root 2. Now, I will explain. Now, when you are simplifying solve problems, the basic or the simplest way you can use is applying the LCM method. Okay, so if I should look for the LCM of 8, the lowest number that's going to 8 is actually 2 and gives us 4. Also 2 into 4 gives us 2, and 2 into 2 gives you 1. Now, when you have done the LCM, this is what you're going to do. Start grouping in, group pair 2, 2. Now the first two numbers I have that is the same here is 2 and 2. They are 2. Although we have 3 numbers that are the same, we have to group in 2s. Okay. Now the last number I have here is 2. So the one which you have circled, you have to multiply them. So 2 times 2 gives us 4. So it means the 2 numbers I will use to replace 8 is 4 and 2. So it means root 8 now is the same thing as say root 4 times 2. Right. Now because 4 is rational and 2 is irrational. Okay, now without wasting time, the square root of 4 will give us 2, which is the 2 outside, and then what do we have inside the root length? 2. So this is exactly how I got 2 root 2 as the distance between A and B. Okay, that is question number 1. Let us solve question number 2. Right. You see how simple it is if you understand how the formula works. The first thing you just need to know is know the formula. And when you know the formula, then you are good to go. Alright, you are good to go. Now let's solve question number 2. Now question number 2, we are told to find the distance between P and Q. And coordinates of P are minus 3, minus 4, and coordinates of Q are minus 2 and 2. Of course, what you're going to do is to label. So here becomes x1, y1, x2, and y2. You must do this, so you don't get confused. Now let's go. Formula says distance between P and Q is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, good. Now, it is good to bring out the formula so you don't make mistakes, so you know what you're doing. So now, the distance between P and Q now becomes the square root of, now x2, according to our coordinates, is minus 2, minus, x1 is also minus 3. All squared, right? Plus, now y2 is 2, minus y1 is minus 4. Also all squared. Alright. Don't get confused because of the negative sign. Just work with them. Now the distance between P and Q becomes the square root of, now I have minus 2. Now minus times minus gives us plus 3. All squared plus. Also minus times minus gives us plus 2 plus 4 all squared. Alright. And let's proceed. Now without wasting time, here I have distance between PQ becomes the square root of. Now minus 2 plus 3 gives us a positive 1 raised to the power of 2 plus 2 plus 4 gives us 6 raised to the power of 2. Alright. Now the distance between P and Q becomes the square root of, now 1 raised to the power of 2 means 1 times 1, which is 1. Plus 6 raised to the power of 2 means 6 times 6, which is 36. Alright, so therefore, the distance between P and Q is the square root of 37. Now, 37 cannot be further simplified. So we are going to make our answer in this form, root 37. So class, this is how you can actually apply the formula for solving distance between 2 points. I believe you understood the how you can prove and also how you can apply this formula. So class, we have come to the end of today's teaching, and I hope you've learned something new. If this is the first time joining us, don't forget to subscribe and also help to share our videos. Thank you for watching, and bye for now.